Hey everyone, welcome back and thank you so much for continuing to hang out with us today as we celebrate Amazon Aurora's 10th anniversary. My name is Adrian San Miguel. I'm a principal partner enterprise architect here at AWS and joined by my good friend Aditya. Say hey.
Hey folks, my name is Aditya Saman. I'm a principal database specialist solutions architect, and I get to work on the star of the show, that is Amazon Aurora. Now, speaking of star of the show, next we're going to talk about everything scalability. How do you scale up? How do you scale out? How
What
do you
is
scale your
scalability?
reads?
What is?
What is scalability? Well, I don't really know, and that's why we have our next SME, the next OG, David Wine. David, do you want to introduce yourself real quick?
Hello, everyone. Hey, guys. How you doing today?
Good. Good.
Hi. Yeah. So I'm David Wine. I'm a senior principal technologist on Aurora, and I've been around nearly as long as Grant, but I have been around for the creation, the launch of Aurora Postgres, and have been sort of just a lead engineer on the team, then managed the team here and there, and then had the great privilege of leading the development of the Aurora Postgres limitless database. So,
Yeah.
Wow, that's a mouthful.
Yeah,
Yeah,
and,
yeah.
and you know, really, database technology, the foundation, that's all great. But a database is only as good as its scalability. Can it scale? Just like for the PC gamers out there, can it run Crisis? It's kind of like that, right?
yeah.
So, what can you
So-
tell us about Aurora's scalability?
Yeah. So the scalability was actually one of the first things. You know, it's funny. I looked through my email and I found my very first week at Amazon back in early 2016. I sent Grant McAllister, who we just heard from. I sent Grant an email. I'm like, hey, so I just joined this team. I'm supposed to be working on performance. Let's talk about that.
Okay.
And so Grant and I have been working on scalability of Aurora for about 10 years. And in databases, obviously its performance is so important, but scalability can come in lots of different dimensions. And so one of the innovations that we've worked a lot on is our serverless scaling. So this is in-place scaling of the compute to go along with that detached storage scaling that you saw earlier. There's some really great innovations in there. We're going to poke at those today. I'm going to give you some demos there. Another key aspect of Aurora architecture is read scaling. So can we scale our reads in addition to scaling our writes? And then once all that is done, we built limitless database, which lets us scale then writes across multiple systems. So in this segment, I'm going to talk to you guys. I'm going to show you folks watching along some of the great scalability aspects of Aurora.
Dave, I have a question for you.
Yeah, sure.
Do you
Sure,
have the
DT.
same guy who names all of your products? It's like serverless and limitless. So what's going on there?
I think, DT, the only thing I can say is less is more.
Okay. Okay.
So, all right.
All right. Well, you have some demos for us then.
Yeah, I have some demos. I'm going to show you, the first thing is I'm going to show you our Aurora Serverless V2 architecture.
Ooh.
So there's some really great things that we launched an Aurora Serverless initial version where we would sort of behind the scenes replace your EC2 instance with bigger ones or smaller ones, causing some interruption as it went up and down. But we said that's not good enough. What we want to do is we actually want to create a special EC2 instance that itself can scale up and down. And then we're going to tie the hypervisor for that EC2 instance into a special customized operating system, into a special customized version of the database engine. We're going to let the whole system move up and down in size while your workload is running. Peter DeSantis did a great deep dive on this in Monday Night Live, reInvent 2023, and you can, if you want to see the real deep guts of the tech, you can go watch Peter's talk. But I'll just show you kind of how it works here. So I'm going to go over here and I'm going to first connect to my database. So data is a serverless database. It's sleeping, and when I connect to it, even though it's sleeping, it's not accumulating any compute. When I connect to it, we are still able to listen to your connection attempt, and we will spin the database up and run. All right. So we're now connected to the database.
And most importantly here, if it's sleeping, that means you're not paying for it, which is one of the value propositions of Aurora 2. You only use what you need and you only pay for what you use.
Right. You're not paying for any of the compute if the compute is sleeping. Yeah. So one of the things I want to show you within this system, first off, just show you that this is a database that's set up with this is the data tables, but there's indexes too. It's sort of 30-ish gigabytes of data. And this is, if you're familiar at all with Postgres, and I'm not sure who following along is familiar with the Postgres PG Bench tool, which is a standard Postgres benchmarking tool. We're going to play around with that today. But this is a schema. It just shows like a simple banking application with branches and accounts and stuff like that. So in databases, one of the most important things for performance is your buffer cache. All right. So your buffer cache is how much memory do I have for caching all the data? So I can give quick responses. So I've got a little procedure here that will show me how much buffer cache I have in this database right now. And right now I have a very, very modest 128 megabytes because this database isn't doing anything. So one of the real innovations we did is we actually did surgery on the buffer cache in Postgres and in MySQL to let it resize while the system is running, so you can get bigger and smaller, and we're going to see that in action. So I'm gonna kick off a benchmark run here that's going to run some banking transactions against this system. All right. So it's starting out. It's running 8 different threads that are doing transactions, and it's running, and you can see the throughput happening here.
And it always starts with a vacuum. I mean, our Postgres folks, I'm sure they're in love with vacuuming, aren't they?
Yes, it's a very tidy database, tidy database. All right, so let's take a look at what's happening here while this benchmark is running against this little small system. Okay. So let me go over to CloudWatch. I'm going to show you a CloudWatch graph. So
graphs are good
here, and we're looking at 1 second metrics as this thing's going. We've got a line here of the Aurora serverless database capacity. So this is how much you're actually using in your compute capacity, and we can see that it has scaled up.
And it started at 0, which means that it was basically at nothing.
Yeah, it was at nothing. The green line is the maximum I've had it configured. So I've thrown enough workload at this thing to just hit the max right away. All right. So let's see if we get... This is another chart here. If I refresh that one, this is showing us the number of vCPUs my EC2 instance has that's running, and you see that this number it hadn't even been reporting because it wasn't running. As we've scaled up, we've increased the number of vCPUs dynamically, but we have a very high load. All right, so we're gonna make some changes here, but I do want to show you. Remember, I showed you the buffers of this little 128 megabyte buffer cache.
It's grown.
So now it's 11 gigabytes. Oh my God,
that was quick.
Yeah. So now we have 11 gigabytes buffer cache. The engine's been running the whole time. There was no reboots, nothing like that. So we want more. So we showed serverless scaling, but we want some more. So I can go to the RDS console. I can just take this cluster. I can modify it.
Okay.
Wow, what's with you folks and modifying it in live production? Grant did the same thing.
We'll do it live. It's not testing if you don't do it in prod. Everybody knows that.
We'll do it live.
Let's do it live.
All right. So 16 gig cache, I had 32 gig database, something. I'll be wild. I'll give it 64 ACUs, and I can actually also dynamically change how much it wants to scale down. So let's do that, and I can just while the system is continuing to run, I think you can see in the window there, we're still
chugging along.
Yeah, and those two bounds are just so that the system doesn't go wild, right? Like you can basically say, okay, you cannot scale more than the max ACUs.
Yeah, exactly. Like it's budgetary. Right, like so we can think of it like, hey, I had a development system. This is my own development system I was working on, and then now I'm running workload. It's more prod, and so I'm going to reconfigure it for that. There's other things that we can do here. So it's interesting. I have an informational recommendation: add a read instance to your cluster. All right, why not? So I can just go add a reader. And I can add another serverless instance, or I can add any of our compute instances, even the provisioned, even a 48XL big machine to the same cluster. But I'll just follow the recommendations. And when we add a reader, I'll give it a name.
You always have to use a name.
Yep. That is going to attach to the same underlying storage. So we're not going to do any copies of storage or anything like that. It just attaches compute to the same storage. You'll notice our throughput's gone up a little bit from where it was.
Yeah.
I'm going to go back over here to our dashboard. Let's refresh this widget here and take a look. And we can see, wow, all right, so we used to be maxed out here, but now we're scaling higher and higher. So our scaling is kicking in. our number of vCPUs has gone up more, and our load relative to the number of vCPUs has come down.
Right.
So
that makes my heart happy.
yeah, so this is in-place serverless scaling, and by the way, we can go look at our buffer cache now is 16 gigs as we've scaled up, and it will continue to scale up as we go.
That is amazing.
So-
and all of this is happening in place, right? Like you don't have to think about server sizes. I know you talked about EC2 instances a couple of times. I just want to call that out for the folks who are listening in that you're not actually creating any EC2 instances. This is all dynamic. It's all happening under the covers. We are taking care of it for you.
Yeah, yep, absolutely. We are managing it, and it's again the same. It's the same fundamental compute that's running. We will dynamically resize the memory on the host. We will dynamically resize the database. We can even live migrate to other hardware if necessary while the database is
Now,
running.
you said something that tickled my lizard brain.
Yeah.
Change the memory. We've gone up. Can we go down?
We sure can, actually. I mean, if I
All right, the old VMware admin in me is very morbidly
so
curious.
we'll call an audible here. I'll just kill this workload. All right. And what we'll do is we're going to move on to the limitless portion of the
Oh yeah,
or-
we want to see how you scale
limitless, but we'll come back.
Okay.
Before we wrap up, we'll come back. We'll check the buffer cache size again, and we'll check this CloudWatch
Sounds
node
good.
again, and we'll see how it's going. All right. So let's see. Let's I'm going to kick off something on limitless database for you.
Okay.
All right. So what I'm going to do is I'm going to run. I got a system running. It's empty, and I am going to put data into it. I'm going to put in 1 billion rows of data.
Oh, you
1
forgot to
billion.
do.
Yes, the 1 billion rows of data.
There you go.
So I'm going to run this script. It's going to create it's going to create a schema behind the scenes. That's going to distribute tables across this sharded system. It's going to load data. It's going to create indexes. It's going to do this stuff. How long do you think it's going to take 1 billion rows to get into this database?
Chat, what do you think? I say maybe about 4 or 5 minutes. Maybe.
Yeah,
I don't know.
That's
Maybe more.
Yeah, I mean 1 billion rows. Well, I'll do a comparison for you.
Okay.
I'm going to run it against Limitless. I'm going to run it against a regular Aurora. So let me kick it off.
Okay.
So this is populating the PG Bench data. It's going to create a schema for me. So it's going to run some create tables within Limitless database behind the scenes. That will automatically, without you having to do anything special, do transactional DDL propagation out to all the shards on the system so they're the correct things. And now my client is loading data in the system.
But while it does that, Dave, can you let the folks out there know what Limitless is? I don't think we talked about what Limitless is.
Yeah, and actually we'd be curious in the chat if you guys are familiar with Limitless, if you watched any of the reInvent talks. So Limitless is a managed sharding solution that we built for Aurora Postgres that gives you a serverless endpoint that lets you scale out writes horizontally. We've done scaling up to millions of commits per second. So, Grant was showing you 300,000 writes per second. Limitless, I can show you. I'm not going to do it today, but I can show you millions of writes. I could, but I won't. Millions of writes per second. And one of the cool things that we've done versus like a lot of other Postgres sharding solutions is we built a transactional system for it. That's a distributed transactional management system. So you get the same exact semantics you get in standard Postgres in terms of read committed, durable commits, atomic commits, all that stuff, all the nerdy database things, low level stuff. You don't have to worry about any of that complexity. We take care of it for you.
And by the way, this is such a huge deal. I don't think that people who have not worked with sharding may realize this, but actually having transactional consistency across multiple shards and treating it as a single database, that is huge. That's an engineering feat.
We're super proud of that. We built on some great technology from EC2 with distributed clocks, and it's really quite cool. So we'll see as this thing wraps up. Well, we just finished loading the billion rows, and now it's going to do a validation. Make sure the correct data is there.
You got to validate the data.
Got to make sure that my thing did it correctly. Yeah, I mean, you just,
well, I have a feeling that the naming guy is going to be super happy because, as I understand, Limitless uses serverless.
Limitless is based on serverless. Yeah, so it's just one of the nice things about it because you don't in a sharded system you often have to be like, well, which shard? How do I size each shard? Blah blah. We take care of that. So so here's your billion rows. So there's the billion accounts, and summed up, I created this system so that the total amount of balance in these counts, we can call it, maybe it's AWS credits, right? We have 100 billion AWS credits. Now, the other thing that it did while we was just chatting is it created indexes. It created primary keys, unique primary key indexes across all these tables. That in total, we just put 154 gigs of data into the database. We created indexes on that. We created an index that's about 30 gigabytes in size. It did it in 38 seconds. So very nicely parallel. And so let's now take a look at this system and see some of the transactional aspects of it. So I'm going to go over here. We're going to come back to our buffers at the end real quick, but I'm going to go over to use my limitless system.
Okay.
I kind of get it, right? The scale up needs to be instant. It needs to be quick, but scaling down has to be gradual. You can't just start chucking those pages out, and it can create a performance issue.
Yeah, absolutely. So we'll just go at the end and see how far it scales down before we're done. So we're in limitless now. And I can select the sum to show you again. A balance from PG. Yeah, see, the live typing is never easy.
Oh. It looks like out in the chat, AM Grability is calling out we didn't do the demo dance. So this is what happens. There we go. Now it's just going to work now.
It's the middle of the demo dance. It's still a demo dance. It still counts.
All right. So I'm going to now run a PG Bench workload. So we've got 100 billion credits, right? What I'm going to do is an interesting transaction. This is not the standard PG Bench transaction. This is updated to transfer credits between accounts. So it's going to be a debit credit between accounts. And the really interesting thing is it's going to choose different branches. We're sharded based on branches, by the way. And it will ensure that one account is on one shard, another account is on the other shard. And it's actually going to do these cross-shard transactions. We talked to a lot of Postgres customers that use sharding, and they're like, hey, yeah, all of our queries, we just send to one shard because that's what our technology can support. We would like to do cross-shard queries, but the technology doesn't support it. Well, here we have cross-shard queries and cross-shard writes. So I'm going to kick that off. All right, so we're running, I should have got a little more concurrency there, but we're running about 1,000 a second. All right, we could hit it with more, but we're running 1,000 a second. So we're doing 1,000 per second transfers between shards. Mm-hmm. And now let me go, while those 1,000 per second are running, I'm going to just keep checking how much I have in sum. I'm not adding money into the system or credits into the system, not taking away. I'm just moving them between accounts.
Yeah.
There's transactions that are running.
So technically, that sum shouldn't change.
Some should always be the same. And I'll even show you if I actually sum up from those 100. I'm going to scan the billion rows here and do a sum live across a billion rows. It's going to take slightly longer to sum because it's looking at a billion rows. But
and
again,
it's getting it from shards, like shard 1, shard 2, shard 3, and then it's putting it together.
It's going across automatically to all 7 shards that the system has right now. It's doing the sum.
There we go.
100 billion. And those shards, again, they're running. Right now, we're doing 800 a second, moving things between. So it's able to still do a consistent view. So that's a quick look at limitless. And that aspect of scaling, let's go back to our serverless V2.
Yeah, let's see if we have
we've got about
shrunk our buffer pool.
We've got about a minute left. I'm going to hold you to account on it.
We're back to 11 gig.
Very good.
We had gone up, all right? We can just look at our capacity and how it's changed over time. So we had scaled up. And you remember I reconfigured and I added a much higher maximum and I added a higher minimum. So now we've just scaled down and we're running now back at the minimum I've configured. So it won't scale down further than 11, but I could reconfigure that minimum even back down to 0 and then it will go to sleep. So there you have it. Different dimensions of scalability in our Aurora journey.
Amazing. That was so thoughtful, so insightful. Thank you so much for your time, Dave. We learned a lot, and very soon we're going to come up for our next segment. So stick around, and we will be back and talk about some MCP.
All right. Thank you, everybody.
Thanks.
Take care.